Okay. All right. So, okay. So yeah. So you should also have a diagram mappings for this example. So yes, as you can see, it's a bit more complex. There is more things going on this time. Through the account mapping, you can see that everything is derived from the consortium account. It all references back to it, and that's sort of the main starting point. All accounts are PDAs in this case. I know there were a few questions about are there any advantages over non-PDA accounts, and I keep asking the core developers. I don't think that's the case. I think there's no advantages at all, but sometimes it's just easier to deploy it and so on. So yeah, they're all PDAs in this case. And the program we want to build is one that basically allows you to propose issues, vote, propose issues, propose solutions to those issues, and then allow people that are part of that group to vote on what's the best idea or what's the best solution. Members are added by a chairperson, and answers can be added by whoever's got the right permission. Yes. I mean, it's basically Slido. You could think of it as well without the votes, or a Eurovision voting thing. So let's go over the flow of it just quite quickly. So first we have to initialize the consortium PDA, which is going to have the chairperson public key, which is the manager. The PDA scheme is going to be derived from their key and their account address. Then we will add a new member. Then we're going to add a question. Then we're going to add an answer for it. And then the vote's going to happen. And then at the end, the chairperson will vote. We'll call it. And only code. Well, it's not in here, so I can't show it. Okay, sorry guys. Okay, yeah, sorry, my bad. Let's see if it opens correctly. Not quite. I don't think I have a extension for it. All right. Okay. So anyway, we'll get to code anyway soon enough. Okay. Well, anyway, the last stage is basically calling it, passing all the accounts, counting the votes, and setting the winner for that vote. So okay, let's go to the code. So this is the file. So let's start at the top. So yes, these are the functions that we specified. So initialize consortium, add member, add question, add answer. Before any function happens, there's context. So let's start with the initialize one. So create consortium. So yeah, we're gonna be calling this, and again first, so we got seeds. So it's a PDA. The schema for it is that we seed as a string, which is passed from the client side. So a seed will be that string, as well as the chairperson's or the callers, the initiator's public key. We could just use the callers key, but hypothetically it's possible for a person to manage multiple different voting DAOs or consortiums. That's why it's nice to have ability to add multiple of them. Then the calling person marked as mutable because they're going to be having the money taken and paying for the creation of it. And then mandatory tree system program, which is needed for a CPA invocation to the system program, telling it, please make this PDA for me, I'm the program. Let's see what else happens in the function. That's sort of it, really. It's just initialization. So we basically get the local consortium struct, and we set the chairperson key, chairperson public address to be equal to the key of the account under chairperson. That's going to be a user for access control to ensure that the right person can call. So that's the first stage. Now the next one would be the add member. So let's check what the context for this is like. So for the add member, similar, although we have a constraint now, and the constraint is that only the chairperson can be the person who can invoke that action. If that fails, it will not proceed. So again, these are the accounts. So these are all the accounts. The constraint can use any of these accounts in order for it to do actions. I mean, it doesn't have to be constraints. You could use seeds and have them derived from any of the other keys or addresses of the other accounts. And this time, the member account is going to be derived from the consortium key, as well as the member's public key. So the person that is calling, that will allow that person to vote on all the answers for each of the proposals as part of that consortium. What would we mark as mutable? Well, we mark consortium because we're going to be mutating it, and likewise the chairperson because they're going to be paying for adding a new member. And then let's go up to the function, add member. Okay. So yeah, just initialization. So members weight. So the vote will have weight, as in just like in an organization, there could be a seniority level or your commitment or how much stuff you've done. So we've made it so there's a different voting weight. For access control, we set the key of that PDA for that person to be equal to the member that you want to be included in it. So it will be derived from them, but also there's going to be a key which is them. That was the easiest way of doing it. We'll just see later. And this is the flag, which allows person to propose answers. We may not want everyone to be able to propose answers. Maybe some people have a sick sense of humor and they'll just spam it with any random stuff, or again, maybe something to do with seniority. So this is a flag which only a certain members are able to use. So, okay, so we've added a member. After that, next step would be adding a question, for example, where we want to go for the workouting. So this is the function, and before the function, there's going to be macro function applied to it, just like the previous one. There's C, so it's not the PDA. We're initializing it, hence there's no need to mark it as mutable, and the C is for it. So this time we're deriving it from consortium key, which is the public key of the consortium, as well as the counter. So the counter is again needed if you want to have a multiple questions added. Other stuff is just you just have to have it. You could pass a custom bump as an argument. I'm not sure whether it'll be quicker, whether this one would iterate over them until it gets to the right one. There wasn't really documented anywhere, and I asked, but I didn't get an answer. Specify the payer for the deployment is the chairperson, and the space is 180. So that would be the next PDA, which is the question. Accounts are going to be mutable, it's consortium, chairperson, and the necessary system program because we will be creating a new account. So this will create a PDA, which is going to hold the question. And let's go to the function now, just at the top. Add question. Okay, so yes, we're getting instances of structs here from these accounts based on the templates we have derived below. And then we're setting the fields appropriately to the provided arguments. So these are the arguments, which is the questions or an issue, and what is the deadline. So we've set a deadline for the vote. So these two fields will be set, and then we're going to mark the question count +1. So then another question can be added without running into the issues of that PDA existing already. Next sequential step. Actually, I don't think I showed the accounts, only showed the diagrams for them. So sorry, sorry for that. So these are the accounts. So we started, I suppose, from the top down. So this is the consortium with just two fields in it, number of questions, who's the manager, and there's a member, which is their public key, how many votes they have, and whether they can propose answers. And then there's a question which you just went over, which this is going to have what are we solving, and a deadline, and the other fields are going to be used up later. Okay, so the next step after that is add answer. So there we have our function, and here will be the macros which happened just before it. So okay, so quite a few constraints here, but again, it just saves us from doing stuff later. So what we're ensuring here is that to answer to a given solution, well, the member calling, which is one of the accounts, okay, this isn't the caller, this is the PDA of the caller, which is going to have their settings involved in it, has to have that field set as true because only some people will have a certain access. We have to ensure that the deadline for answering this question has not expired yet. So we're fetching the clock from chain and ensuring it that it is smaller than the deadline we've set. This is just the standard UTC timestamp. One more flag, we're ensuring that the winner has not been selected yet. So that happens after the chairperson calls in the end of the vote. And the last thing, which was actually quite elusive for us for a while, was that we have to check that the key of the owner of that PDA matches the key of the caller. For this to proceed, the signature for that account has to be provided because the person is changing stuff. But by having that signature, we also can ensure that this is that person. But it is possible, it could be possible for someone to call, sign for themselves, pay for the account deployment, yet provide a PDA for someone else. And that would be a security hole, which we'd want to avoid. So we are running a check to ensure that, yes, that person is a caller, but also the account that they provided is generally owned by them. Should these constraints work, we can go to actually generating that account. I mean, this is the normal stuff. We're saying who's paying for it, which is the wallet calling, the member, the signer, and the seeds. So going back to how do we derive that seed schema? So we're adding an answer. There might be multiple answers. People can propose them. So we're going based on the PDA will be derived from the question key, which is unique to that question, and that itself is derived from the consortium, but also to the counter. So on the client side, you could easily derive over consortium, get all the questions, and from getting all of the questions, you could iterate over them and get all the answers. So that is the seed schema. The rest of the accounts, which ones are marked as mutable, which is so the question, why is it marked as mutable? Because we're going to increment the answer counter for it. Remember, because they're paying, and I think I think that happens twice. Maybe that's not needed here because I think that's the same check. But that's it. So this is the add answer. Any logic that couldn't be contained there, except maybe for using traits, we're gonna have a look into now. So similar syntax to above. We basically get structs which we can interact with in a Rust function fashion rather than having a serialized objects. And yes, we're incrementing the counter for the questions, so just +1. And then we're setting the answer to that issue to be equal to whatever has been provided for the client as the argument. Again, this is anchor. The question account and the answer account has both been marked as mutable, so we don't have to explicitly state that at the end of it we'd like to serialize it and put it back in. It's just going to happen here. Without it, we'd have to do it ourselves. Next stage, which is vote. So for vote, let's see what the context for it is. Okay, so again, PDA have more constraints. The constraints are, of course, you can vote only before the deadline. You have to ensure that the winner hasn't been selected yet. And just like with the previous one, we're running the check to ensure that the person that's calling, which is this account, actually is the same person which is under that struct. And of course, that struct is the one that allows them to have rights to vote for this. And system program, because we're creating a new PDA. So yeah, sorry, let me actually talk. Why are we creating a PDA? So that is just one way we found of doing it. Should you want to have a different voting mechanism that are a little bit more advanced, that might not suffice. But how do you ensure someone voted? Well, at the end of the whenever you count votes, you really only have to iterate over answers and just see which one has the most votes, right? All the other accounts that didn't vote them, they're actually of no concern to us. So one way of go about it, which we've just picked here, which is that after you call and then you place your vote, we just create an empty account. If you try to call again, you won't be able to, because the schema for it is always going to be the same. And this is what this account does. So you can see here that this account, unlike any other ones, is not really used for storing data. It's more as a access control to prevent us from doing it again. But of course, there's other ways of doing it, but I just thought this one was quite interesting to do. So yeah, this is just an empty account, but any account that it lives on chain has to have money stored on it, and then we can check whether that exists. So that's that's what happens with the vote. And the seed schema for it, which is the member key and the question key. So next time you call it, there is no counter, there's nothing. You will try doing the same thing again and it will fail. Other accounts, so okay, so it's the same as before, member struct, member, question and answer. They're not mutable. So, I mean, the answer is, but not the question, because we're not changing it. We're only using it as a lookup. So let's go to the actual function. Vote. The same syntax as above. We're getting structs which we can interact with, and we're accessing members weight because they can have different ones. We're casting it as U32 because this is what's needed. So okay, let's actually talk about that a little bit more. So each of the member, their weight is as U8. So the highest amount they can have is 255. But the where is the consortium question? Okay, but the actual votes cast per each of the answers is U32, which is I can't remember, but 20,000 something, I think. So it means there are actually two different variables. They're of course they're the same. They represent the same thing, but one's got a different number of bits. So Rust wants us to be safe, unlike C, and we have to cast it as the intended type. And that's what happens in that line. So we take members weight, we cast it as U32, and then we append it to the total votes added to that answer. Should there be any other voters? Otherwise, it starts from 0. So this is the vote finished off. And now we're gonna go to the last function, which is the tally, which is the same as basically counting votes. So let's see the context for it. Okay, so we're ensuring that the color is a signer. We're, checking that the color's key equals the chairperson, as he's the person we intend to be able to call, and that the deadline is actually smaller now. That means that the time has expired for it, and that the winner selected has been false yet. And we're marking question as mutable because we're going to be writing to it, and consortium we're going to use just as a reference for some other operations. And yeah, this is the very confusing and also interesting part. Let's go to the tally bit. So actually see we've added quite a few messages here for you to make it easier later to look at it. But why is this kind of awkward is that we're going to be passing many accounts. So we have to loop over all of the answers. We'd like to do it in one step, ideally, rather than doing it all the time. But as you can see, the context is they're providing only context. So we're only providing these accounts, the ones specified here, they're always provided. They have to provide it for that functionality. But on top of it, we're going to have to provide all of the answers. And that could be 5, 10, 15 of them. We can't actually list them here. But there is an option with an Anchor framework to add basically accounts that aren't included in the context, but we're going to use them regardless, which is what's going to happen in this function. Okay, so again, this is similar to before. Well, at least this one, which is we're getting a local instance of question, which we can operate on. But here's the more interesting part, which is we're basically getting all the remaining accounts. So let me see how it's done in the client. Vote tally. It kind of looks like this. So first you provide all of the correct accounts, but correct, all the ones that are specifically to be included for the context to work. But at the end, you're just providing anything that's left over. Think of it if you're, for example, doing an airdrop or doing anything that might be repetitive, but there is an arbitrary number of the accounts to be passed. So this is the syntax. So first you provide all the accounts, but here, this is, as you can see, this is the same kind of syntax that we had without using the anchor, where you actually have to say, is the account writable, the signer. So, basically you're telling whether it's an account or whether it's a program. And here we're going to be basically unpacking it. So we're creating a vector of leftover accounts from using the syntax. So context from any account, we're turning to a vector. This is going to be just a variable, a tuple, which we're going to use to see who the winner is, where this is the index of the winner. It's U8. I'm assuming there are not going to be more than 255 submissions, but of course, if for it to scale in some crazy projects, maybe that's not the case. And these are going to be the total votes cast per that given answer. So there's a bit of logging here. And here we come to the point where we have to do quite a few checks to ensure that the accounts passed are actually the correct ones. So first one is we check that the length of the provided answers that weren't included in the ones that are needed by the context is the same as the answer counter in the question struct. Should you provide one less or one more, it would fail. Okay, so that's one check. But okay, here's going to be another big check, which is, how would you ensure that people are feeding the right account? Well, we know what the schema is. We know we can go over the counter, and we know what the next one is going to be. So we can rederive it and compare the PDA that we rederived on chain to the one provided by the client. So that's what we're going to do, which is we're calling a function to rederive PDA here. And here we're basically comparing it to see whether the PDA that we rederived here is the same one as one of those which we're looping right now. So that's what we did. We changed it into iterator, and to enumerate it off, we basically have an index, which we later can use as a basically as a feed to who the actual winner is. So this check in here will actually require the accounts to be provided in the right order, because we were sequentially checking it. You could make it so you can provide them in any order, but with this kind of stuff, it's better to offload more work to the client rather than do it in on chain, because of course it's easier, as it's more awkward, and then you pay for computation. So yeah, the accounts, no matter how many there is, but they have to provide the right amount, and they have to be in the right order. So provided this thing works, we basically will cast now that answer, which we're using right now, as that account type, which is at the bottom here, which is the answer one here. Basically, we want to be able to access that variable, but at the moment, that account is just generic binary code. We have to cast it as something that we're able to work with. Okay, so we get a variable called temporary answer. And okay, there's a bit of logging going on here. And the algorithm for basically checking who the actual winner is to, yes. So at the moment, if you see that tuple is initialized to 0, so at the moment the winner is index 0 and it's got 0 votes. And we're looping over it, and we're checking if the temporary answer votes, the field under key votes is bigger than winner's index 0, which is set to 0. Then we're gonna overwrite it with the newer one. So the new votes will be these ones, and the index will be whatever this index from the numerator is. Once we finish it, we looped over all of the accounts. We know what it is, and then we can set it in the actual question account. So it's basically marking that that's it, we found the winner. So winner index is set to the first, second, or whatever, first, second index of winner, which is the tuple. And we mark that the winner has been selected, and then there's a message for exit. So, okay, that's it. I know we'll go over the test, but I know it's kind of an example you guys have been thinking of, something to do with democracy. So that's kind of quite similar. But again, there's many ways to do it. And as I said, some stuff will only work in, for example, with the way we mark how the vote has been done. So let's see let's try running it now. So I'm not sure whether Anchor will make me redo everything again with the seeds, but actually no, it's Anchor build. So okay, so we're after example 3. So that is program ID. I think I've already done it, but let's double check. Okay, that's the same one. And in Anchor, okay, it's the same one. People mentioned, yes, there is a way of checking it, but there's no way to programmatically to do it with Anchor. But yes, you can find the key without having to do this, but just, I guess, I'm a creature of habit. So okay, that's been done. So that actually this deployment is unnecessary. So here are my logs, and in some other shell somewhere else is the validator running. Okay, so that worked. So again, to run the tests, we would go Anchor run test 3, and that will execute all the tests in here. So let's have a look at the test first. So okay, there's a lot, but that is kind of the theme in a way. Just like with hardware design, you spend a lot more time validating things and verifying it rather than developing it. And really, all the unhappy paths have to be checked. Of course, I mean, it's a little bit easier in Solana because the deployment costs are a bit cheaper than in Ethereum, but it's still good to make sure stuff works, especially if there's a lot of money involved. So let me hide this, then we can go over the functions, or yeah, the test cases. Okay, so all right. So I hope this is exhaustive, these tests, but there's always room for more. So first we'll create the consortium account. We'll see whether it's been a lot of sanity tests to see whether some things are set to 0 or the member's key is set right. We will add the member as the chairman, which he's got privilege to do. We'll add a member with slightly different settings. The things we can vary are the number of votes, as well as the ability to add proposals. We will try to add members as someone who's not a chairperson. Then we will add a question as the chairman. We will add an answer to the prior question as someone who's got a privilege to do so. We will attempt to do the same thing as a member who does not have the privileges to do so. We will, oh yes, so going back to, let's actually go to the member here, to the context is, one of the potential holes was the fact that both for voting and for proposing answers, should there be no check, you could actually you could call as anyone and provide a PDA that isn't your own one. So in here, in that test, we will check whether the caller is also the same person as under the account they're calling from. So sorry, what was this? So add question, not about an answer. Sorry, yeah. So basically, yeah, that's going to be a test that these two have a mapping, and the person here is assigned is just the same one. So you can't just find a right PDA that's got the privileges and just pass it as any old Joe. So this is going to be that test. Then we will vote cast as member 1 for answer 1. So submit an answer. Okay. We will add vote as member 2. We'll cast a vote as member 3. So there should be different number of answers, different number of votes per given answer, which the looping mechanism in the final tally function should be able to process. Again, we'll try calling voting using the PDA of someone else. Then we will try counting votes with if you don't provide sufficient number of accounts. So for example, there's been 3 answers, but we we don't want the guy to win that we don't like to provide it to, for example. So that check would should fail. And then we would call with the right number of accounts, and that should succeed. And at the end, we'll check to see whether the answer that won is the one that has the most votes. So let's go to the top. Okay, so first test. Okay, so let's try this. Okay, so all works, good sign. And then yeah, let's go over the tests. Just one more thing. When writing a test, it's sometimes there's a lot of boilerplate code. This one is a little bit thicker than it could be. You could write helper functions, so you could, for example, if you're adding an answer or voting, but you're using by 2 different members, you could write a helper to redo it to save a bit on code. And it's also important to write tests that while they test everything, they're not in a way too rigid. That's less of an issue with Solana because you always feed the state. But for example, with Ethereum, you could deploy a contract, and upon next function, it won't work, for example, if the previous one hasn't happened. So these tests are quite rigid in that sense that I can't just run any of them. They all have to run together. So if I comment them out, the second one won't work, and so on. I had issues in the past where I wrote basically the tests were stricter than the actual code, and everything was fine, but the tests were failing because it was just a little bit too rigid. So I guess it is a balance, but yeah. Okay, so the first thing. So we're creating the PDA. So we're going to create the seeds from it. So the string we've chosen is just consortium. We create a buffer from it. So there's different in JavaScript. There's different variables that store bytes, but the one that this function wants, you can see in the prototype of it, is either uint8 array or buffer type. The number array, it doesn't want it, though there is a different function that wants it, so it's a little bit confusing. But we're creating it, so the PDA is going to be created from that program ID, and it's also going to be that seed, which comes from that string. And out of that, we derive the consortium PDA. We will call initialize consortium. So let's look at the function. So it has a single argument, which is the seed. And likewise, that is what we're passing here. Oh yeah, good idea. Okay. Okay, this one. Okay. Yeah, so it's the same syntax. You basically go program, which you've imported earlier. Of course, advanced project is going to have multiple programs, so you might have to call it what that program is. Program does this, or program A, program B, but we just have one. So it's program methods. Specify the method. Remember, the casing is different. So here is in capital, here is not. Then we're providing all the necessary accounts. So that's going to be, if you scroll down, which is the consortium, chairperson, and the system program. We're getting the state, and then we're running a few sanity checks. So the question count is initialized to 0. Yes, that's true. It is always initialized to 0, but of course, different logic may require us to initialize something to a different number. That's why that check should be always there. And then we're checking that that under the locally important snapshot of the state, the chairperson, we convert it to string because it's an account, is the same as the one that we've defined earlier. Sorry, just one more thing is that at the top, we basically generate all the accounts that are going to be used as part of this execution. Here are all the PDAs that are global variables, which is just basically easier to reuse them that way. Here are going to be the answers we're going to submit. And here are the top-ups for all the accounts that are required to have some money to do something. You need to make sure you do it. Otherwise, you're going to have an error that means absolutely nothing, and it's very hard to debug. So yeah, top up your accounts. And yeah, that's it. So we just initialize consortium, and we do a few sanity checks. Next function, we're going to add a member. Actually, we're going to add several members. So a constant here, which is member weight. So we're going to have another member is going to have a different weight. That's why I stated. But okay, we're creating as was seen in the diagrams, is we're going to create a PDA for a member. We have to derive it. So the same program, the program is going to be the owner of it. So that's why it's included here. And then we're following the schema, which is the seed from it is made from the consortium PDA, which is a PDA. Okay, yeah, of course it's PDA, and the public key of the person who the chairperson wants to be a member. So that's our PDA. Same format as before, which is cont.program, methods under it, and add a member. This time we require 3 different variables. So we're passing the weight for voting. We're passing whether that person will be allowed to propose answers to a given issue, and the pub key of that account. So this person is not actually passing away here. Instead, we're passing their key in here because their account is not actually needed to be used anywhere. We just need their public key. But of course, we need to pass their PDA. So that's the distinction. There's a PDA of a member, and there's a member. Member is a wallet. That's you. That's a guy that can call and do stuff. And then system program, because every time you create an account, whether PDA or non-PDA, you have to provide a system program. And it's signed as a chairperson because that's the only person that's allowed to do it. And then we're going to be doing tests to ensure that that's correct. So we're getting the snapshot of, so we're fetching the IDL account member. And then under this address, so this is the one we've just created, we check that the weight is set to the one that's above. We check that this person is capable of initiating answers because the second parameter was true. And actually, that's the only check. We could also check for the key, whether key is right, but I guess it wasn't included here. We're going to do the same thing for the second person. So again, that's what I was saying. You could write a helper for it and kind of, or even do it in a loop. That's fine too. So yeah, we're generating a second PDA. This time, so it's still consortium PDA as half of the seed schema, and the second one is the second person we'd like to be the member. And then basically the same logic. This person is also able to vote. Same accounts being passed. I mean, same structure, because of course this time we're passing a different PDA. This PDA is going to be for a different person and signed by the chairperson. And the checks in the end are pretty much the same. So this was the second working test, and yes, the chairperson can add member. I'm going to add a member with slightly different settings. You could include in the above one, but I thought it was sufficiently different for it to warrant its own test. So this one has more votes, or is it more or less? Actually, it's actually less votes. Okay, so it's a small error. And then yes, we're rederiving the PDA, which we're going to feed for the C-level to know that the account can be created. Same as before, except this time is the difference that we're feeding false as the middle argument for whether that person will be allowed to create their own answers. Yeah, and then this is different as well. So the checks we're going to run here will be slightly different. Here's actually the address is checked, but here we check that that person would not be allowed to propose answers to questions. Okay, next check. So a non-chairperson can't add members. So as the way we specified it is just one person can only do that, which is the chairperson. There is no such scheme that a new member cannot, members can add members. No, the authority will rest with one person. So we're deriving a PDA again for an account that hopefully will fail. This time we're not calling it as the person, as a chairperson, we're calling it as a member 4. And because of that, it should fail. So this is wrapped in a try catch block. Should it for whatever reason proceed to here, it will fail. And when we catch it, we assert that we did receive error. You could go in more detail, and if you have custom errors, check that the error is exactly the one you're looking for, but it wasn't necessary. Okay, so we're done with adding members. So that was the first PDA that was derived from the consortium account, and the next one is going to be adding the question PDA. So there's our text. What's the best fruit? Okay, so the seed schema is here now that a given consortium can have multiple questions. So we're going to have to fetch the state to get the question count in order for us to be able to derive it. So this is kind of the syntax I spoke to before is that this will always get you the latest count. I could just hard code it to 0 because I know it's the very first instance of it, but that way it is better for making sure that the tests work without having to be exactly crafted each test run for that case. So yeah, we're constructing a buffer which is going to be the size of 4 bytes, which is going to have just whatever is our latest counter, which is going to be 0. So it's basically going to be 4 zeros, and we're going to use it as 1/2 of our seed. So this is our 1/2. So I'd like there to be an easy way from, but so yeah, we have to change it to buffer. Then again, I'm sorry, no, okay, no, sorry, forget that. So yeah, that buffer from here goes here, and here we create a buffer from the PDA converted to bytes and program ID. Creating any arbitrary deadline, it has to be in a feature. And then same syntax, calling program, calling function add question. We're adding the text which we want to have. There's no checks for it, could be anything. And then we are adding the deadline. So those are the only 2 arguments that aren't submitted as accounts. And here are the necessary accounts, which are consortium, chairperson, question, system program, sign as a chairperson, invoke it. And then we're getting the snapshot of the state of that newly derived question PDA. And we're running the sanity test, which is, well, first we're checking whether the string is the one we've submitted. For example, I mean that would fail, but there could be a way for it to trim. So one thing I've noticed before was that if you have an account that holds a string, imagine it's a string of 20 characters. If you call it again, and this time you set one of 5 characters, you're going to overwrite only the first 5 characters. You're still going to have that stuff at the end. So that's why it's important to check and to set the string exactly as it should be. But in this case, that's not a problem. We are checking that yes, the deadline set on chain is the one that we provided. Our sanity check. No answers have been added, well, they shouldn't be, and we're saying that no winner has been picked, and that question said okay that the winner index has not been set. Next check, which is member with correct privileges can submit an answer. So was the previous one? Okay, so this one was the question, and the next one is the answer, and then the answer is derived from question. The question is derived from the main consortium, say PDA, and then this one is derived from chairperson's key and the program. So member with correct privileges can submit it. Okay, so well, we need to get the index of the answer counter in order for us to derive the right answer PDA. So I mean, here is deriving the buffer, so which goes here, and then we're doing so the same syntax as before, except last time was so it was actually wasn't the same. Sorry. So yeah, that's the PDA, providing it here, providing system program because we're going to be creating a new account, and this is the person that's signing for it because they under they basically have a flag that allows them to do so. A third question answer has been incremented. So yeah, we get the state and for the question, and we check that it went up by 1. We're going to be doing more checks with the answer state. That's why we get kind of a variable here, which we can then answer individual variables. Well, here was subsumed into a single one. So we're checking that the text of the answer is equal to the one we provided, which I think was a favorite fruit, so it's like blueberries or something. And then we making sure that that answer or that PDA, that the field under vote is equal to 0. It's just submitted, nothing else should be there. And then what's going on here? So answer counted buffer 2. Oh, okay, so submitting a second. That's 2 members. So answer PDA 2. Yeah, so we're submitting the second answer as the second out member. So this is member 2. He's using the second potential answer, which is Mango. It's basically the same, but we want 2 different answers because other tests later on will cross-check those things. And the checks here are the same as for the previous one, just for the different account. It's marked as 2, and it's fetching the state from a different PDA. Member without correct privileges can submit an answer. So that's going to be that account, which we've marked as being able to vote, but not being able to propose answers, which was, I believe, member 3. So same steps as before. This guy's quite a joker. He's proposing something that isn't a fruit. That's why he's not allowed to vote. Exactly same syntax, but again, if it should venture here, that test fails, and we know we got something wrong, and here we are asserting that the error that actually happened. This test is to ensure that someone couldn't just randomly take your take a PDA and try to pass it as their own one. Which is, the setup's very the same, except here you see that the member struct, or the PDA of some member, is provided in here, just as that account, but the caller and the signer is actually a different person, and that will fail, and it will likely provide a different error as well, though you can never know with these errors. So that will fail, as it did. Okay, so I'll just go over one of them because the other ones are sort of the same. But okay, so this is the final PDA we're going to be deriving. This one is the not really a dot PDA, but an empty PDA, which we simply use the existence of it to not allow ourselves to allow that for that person to do it again. So yeah, we're doing a PDA. So PDA, this will be per question, because you can vote once per question. This is the person going to be calling. This is the PDA, and this is the program, and this is our PDA. This is for comparing later, because once you vote, we should transfer the votes from that person to the answer PDA, and we're calling vote function for this. So let's see. So vote. Yeah. So basically, these are all the accounts that we're providing. Again, PDA, we have to provide this thing, or you're gonna get errors that mean nothing. And we're signing as the person, because there's a check to ensure that only that person do it. And at the end, we're fetching the latest state of the answer PDA to make sure that the tally has increased. And we're checking that the tally increased exactly by how much that person is able to vote. Yeah, just to be sure. So we have the starting point. So we're subtracting endpoint, which is going to be higher if you have voted from the starting point, and we're checking that that it equals exactly the allowed number of votes that that person has. And here we're checking that that account has votes, has lamports. This one is pretty much the same. I think is okay. This one, okay, they're all actually the same. They're just made by different accounts. In here, we're doing sort of the same check as was done before, which is, can you try to take someone's PDA, provide it, and use it as yourself? So it's going to be there's a member scammer, and basically he's trying to provide these PDAs that aren't his. Sorry, he's trying to provide a PDA and an account that isn't his. So this will not work. This is going to fail. And this function will, so it's okay. So we're the very last one, which is tally. So actually not much interesting stuff in here, but in the last one, as we said before, there will be quite a few checks. And the very first one is this one. So we're checking whether it fails at that. So we are providing just one answer PDA, but we've created 2 answer PDAs and 3 people have voted on them. So yeah, so tally votes fails when sufficient answer accounts have been provided. Again, same syntax, try and then catch and assert the error. And then the final one is we provide all the answers and we calculate it. So same syntax as before, except there's one extra. And now we're actually checking to ensure that the right thing has been voted on. So we get the post invocation state of the question PDA. It should have an index set now. So assert answer 0 have won. So again, this is kind of hard coded, but we have placed more votes for index 0, which is the first one submitted. 2 accounts voted for it, but only 1 voted for the second one. we check that the flag has been set for it to be over. All right, yeah, winner answer PDA. So we're okay. So we rederive the winner answer PDA based on the index rather than based on the accounts we've created later. So if that was a lot of stuff going on, we might not know actually which account it is, but we can retrieve the, where is this a question PDA? Okay, so we fetch the state, get it to bytes. Yeah, well, okay, so yeah, can't exactly say where this is going on just right now, but this check basically ensures that the answer is the one that it should be, and that the text of it is the one that is at the very top, which what is the one we intended to be. So yeah, so for that, just can right ahead, kind of look at it. But yeah, as you can see, that's 650 lines. The actual anchor is quite a bit shorter. If you were to expand it into Rust, it would be longer. But compared to the previous test we had, this one is much more comprehensive. You still could think of a lot more tests, and there will be a lot more tests. And ideally, you catch out everything. We sure had fun making sure this works. But yeah, I suppose this is it for the example. I'm not sure. I guess you guys gonna do more homework now, or any questions maybe?
Yeah, maybe if there are any questions to the code, and again, to confirm that you guys are able to build and deploy that to your local cluster, please give it a try.
Yeah, I have a question about that. So we're working on a voting application, and it would probably be great if we could use some of this code as a basis for what we're doing. I think our app is probably a little bit different in terms of the functionality. Like I don't think we have a chairperson, but maybe a lot of this could be used by our team. So how would we go about using it and playing around with it?
Well, I mean, all these examples are sort of just to show you a variety of different functionality. Honestly, just look at it, modify things, and cannibalize whatever works for you. You can reuse it if your end architecture is going to be different. And you might not have a chairperson, you might have 3 of them, right? Or you might have you might vote with lamports with your balances or whatever. So yeah, it's generally just to show people kind of how we went around it, but there are many ways to around it. For me, what I think is important is having that kind of a referential state that starts from one thing and kind of leads back to it. I think that may simplify things in the client side, but there's many ways of doing it. So yeah, definitely use it as an inspiration. That's what it's there for.
Awesome. And it's just in the repo, yeah, the regular repo. Can we find it there?
Oh yeah. I was using the same repo, so I think it's been pushed just before the class, so you should be able to pull it and run it. And then yeah, I think everyone should have a go, and then we can help you debug it if it doesn't work for any reason.
Perfect. Thank you.
I guess that's it for today. Close out all the breakout rooms for the last people that are here. If you want to say anything from the expert team, otherwise, that's it for today. Thanks, everyone. We will kind of pick it back up tomorrow, same time, same place as usual.
Yeah, thanks very much, guys.
Thank you, everyone.